Hello everyone and welcome to this new video series on wireless security. This will be chapter 1. We'll start our discussion with cryptography. We'll also move on to cryptanalysis, then we'll move on to firewalls, stenography and many more exciting stuff. So let's get started. So when we talk about security, we certainly mean free from danger or any sort of possible danger. So in today's internet world, we hear the most common terms like XSS or cross-site scripting. Then we also hear about CSRF, which is cross-site request forgery, and the most common attack on many websites is the DDoS or distributed denial of service. So these attacks cause a security breach in our networks. And when we talk about a network, in the simplest term we mean a node communicating with another node. So when we talk about a security breach, we certainly mean that there is a third person within these two nodes or another third node that comes into this communication medium or network and tries to break in this network and steals the information. There might be sensitive information, like perhaps you might go to Amazon.com and try to buy a book. If the network is not secure, your data will be lost or perhaps stolen, and your data might contain sensitive transaction information about your money, about your account. So that's really an issue. When we talk about securing a network, the first thing that comes into our mind is cryptography. So when we talk about cryptography, they must meet three important objectives. The first one is authentication. The second one should be message integration or message integrity. And the third one is encryption. So now let's discuss all of these three objectives into more details with an example. First, let us assume there is an user called U who is the sender of the information, and he wants to buy something, suppose a favorite book, from Amazon, who is the receiver of all the information. So in this transaction, in this exchange of information, we see that this is mainly a transaction information or transaction process that goes on in between the two nodes. This is the first node and this is the second node. So how can cryptography, the objectives of cryptography, can achieve a secure network? So when we talk about authentication, it generally means that it is the ability of the receiver, or in this case the Amazon or A, it is the ability of the receiver to determine that the information is being generated and sent by an original client or original source. The client must be genuine. So when we talk about the information being genuine, it means that it should not be manipulated, concocted by an intruder. So there is no place for an intruder to manipulate such an information. So the next thing we'll talk about is message integrity. In message integrity, the data being transferred in between the sender and the receiver, or the first node and the second node, needs to be authentic first of all, and it must only be manipulated by the sender or the receiver. So message integrity is quite similar to authentication, except that the authorized personnel should only have the authority to manipulate the message, and the intruder should not have the ability to concoct or corrupt the message. So in this case, the intruder is left out and only the authorized person is allowed to manipulate the message. The last thing that we'll be talking about is encryption. encryption includes the use of ciphertext and the plain text. So when you talk about ciphertext and plain text is the message that is generated by this user or the sender who is writing something like, I want to buy a book. So this is a plain text message. So when we talk about plain text messages, we talk about messages that are written in natural languages like English, Arabic, French, or something like that. But in computer terminology, when this needs to be transferred through the network, the message needs to be encrypted or converted into a ciphertext, that is a message that has jumbled up values which is incomprehensible to a third-party attacker, and that will serve the data security. So when the message is jumbled up, the intruder has no idea insofar what sort of data is being transferred between these two nodes. So encryption is the process through which a plain text message is transferred or transformed into a ciphertext message. That is called encryption. Now let's move deeper into this cryptography. We'll first start with symmetric key cryptography. And before we move on to learning the symmetric key cryptography, we first need to understand how a decryption process works. So what do I mean by decryption? It's simply the opposite of encryption. When the decryption process occurs, the same ciphertext is transferred back into plaintext. So in this scenario, when the sender writes that I want to buy a book in his plaintext or native language, the plaintext gets transformed into a ciphertext and it's sent through this network as ciphertext, and when it reaches the receiver, in this case the Amazon, it is received as ciphertext. Then the ciphertext is transformed into a plaintext message, so the people in Amazon can understand what this user wants and what is he trying to say. So this entire decryption and encryption process can be mathematically represented. So when we want to represent encryption mathematically, it will be the function of x equals to y. This is encryption. So certainly in encrypting language, we will mean that the message M gets encrypted and it is transformed into a ciphertext C to be sent through the network. So in here, the M is the plain text message, it is the plain text message, and C is the ciphertext message, and E is the function that is encrypting this plain text message and transforming it into C. So when we talk about decryption, this is just the opposite. When the decrypting message or the ciphertext is transferred back in its native plaintext, so mathematically it will be the function of y, in this case y, which is equals to x, and this is the representation of decryption. So in its own terms, the ciphertext C will have its own function D, decrypting function, that will transfer back to the plaintext message M, that will get us back the plaintext message M. So this is simply this. In short, we can actually combine these two equations together and write it in a single equation. So when we want to get back the plaintext message here, the plaintext message, in this case X, by decrypting it, we can simply write, or we can simply put the value of Y in here back into this function as equals to X. So this decrypting function is giving us back the X value or the plaintext value. So in its own term, it will be, when we get to its own terms, this will simply mean that we put the value of C in its function as M to the as equals to M. So simply when we look at the user, one user is sitting here and the Amazon, the company, is sitting at the other end. So what happens is, first the user encrypts the message and the message gets jumbled up like a message that will simply look something awkward with all its weird characters and things that are incomprehensible to a simple human being. But this message, when it gets encrypted, this will look something like this. The algorithm will the cipher will look something like this, and then this is decrypted back to the original message, to A, that says I want to buy a book. That was the actual original message that the user sent.